Hello, everybody. Happy Fossil Friday and happy almost Halloween.
Yeah.
Yeah. Oh my goodness. I am your host, Brittany Stoberg, from the Western Science Center. With me, as always, is Gabriel Sanchez from the Raymond and Alf Museum, who has with him a special guest whom we all know and love.
Got a big hot dog.
Uh,
Well, it's almost Halloween tomorrow. I can't go wear this outside, so I'm gonna wear it. I look cute, and I'm gonna let people see it.
It's perfect. And joining us today is Dr. Meaghan Wetherell. Hi, Meaghan.
Hello.
Oh man.
Oh man.
This is a good episode. Welcome back, everybody. Alrighty. So you guys might have heard that today we are talking about trunks. And considering where I work, I am very excited for this particular topic.
I'm gonna spend the whole time meaning elephants. But yes, absolutely.
I know. And we are talking about hot dogs today. We're talking about trunks. So a little bit about Dr. Wetherell. I told Meaghan before this I really loved her bio, and you'll see why. Because she is a paleontologist, a data scientist, and herbivore enthusiast from the University of Arizona. And her entire career is built off becoming the hype woman for the coolest animals ever, Oreodonts. Long may they reign. And so yes, that is the official bio that Meaghan sent us for this presentation. So if you wanted a little bit of taste about how her presentation's gonna go, there you go.
I'm really excited for this. This is gonna be great.
Me too. All right, everybody. And as always, if you have questions for Dr. Wetherell after this, go ahead and put them in the chat, and we're going to have a Q&A afterwards. So if you've got burning questions, well, we have an expert here. So Meaghan, whenever you are ready, take it away.
All right. Yep. Oreodonts are the best, which is the alternate title, of course, of this entire talk and my life career. So we're going to talk specifically about one aspect in which Oreodonts reign supreme. We're going to talk about trunks and why they are evolution's vanilla latte, meaning that everybody likes them, everybody's had them, and they are delicious. So this talk is going to be presented in 3 different parts. The first part, we're going to talk about what is a trunk. It's not your upper body or the box that you keep your clothing in. It is a big old fleshy thing on your face. We're going to talk about who had trunks and do a little bit of paleontological trolling, which I'm very excited about. And then we're going to talk about how did trunks evolve and cover some of my research into this topic. So we got 3 servings. Let's start with trunks. So first off, trunks, they are not just for elephants. Trunk is kind of a common name. The technical term is a proboscis, but that name is dumb. So we're going to stick with trunks. They are commonly mobile and muscular. They can pick things up like you think of with an elephant, but not always. And of course, there are a lot more animals, both living and fossil, that have trunks than you might have known about, like these guys. So I'm a bit more, or realistically, we're not going to talk about them too much. I'm just going to show you some stupid Google image searches for 3 of the best, the top trunks. So first off, if you're looking at this middle top picture and wondering, oh my God, what is that? That is so cute. You are right and wrong. That is a tapir. And if you've not seen one of those before, let me tell you, they are majestic. Look at those. So a tapir is essentially if you take a pig, but you made it somehow related to a horse and a rhino, and then you slap a trunk on its face and make it sneer most of the time, according to Google anyways, then you get a tapir. The adults look like this. The babies, however, are literally the cutest I've ever seen. They're all soft and stripy, and for some reason, photographers never take their pictures making these exact same sneering faces. So tapirs are going to be a big target of this talk. They have trunks, but so do dik antelopes. Yes, that is their name. It's spelled D-I-K. They look like this, and they are basically the size of a small dog. Very, very cute. And then, of course, look sort of like a Star Wars puppet has sprung to life. They are real, and they are really weird and majestic as well. So trunks, in addition to being very ridiculous looking, which is the primary reason that I study them, they are good for a lot of different things from an animal perspective. So there's a lot of different functions that trunks serve. When you think of trunks, you probably think of elephants, and there's a lot of things that do similar sorts of things with their trunks. So tapirs and elephant shrews and elephants, they all have muscular trunks. So they use them for selectively foraging, right? The tapir doesn't have as long of a trunk, so it's not picking grass all the way from the ground and pulling it up to its face, but it does use it to selectively pick the best tasting bits, essentially, of food. And it's the same with the elephant shrew. But that's not the only thing that you can do with a trunk, as the saiga antelope has shown us. The saiga antelope, as it turns out, uses its trunk primarily as a dust mask. It actually uses it to filter out dust. It has a big kind of hollow empty space inside of its nose. It pulls in air, the air slows down, the dust settles out, and then the air continues on. So it's an air filtration system. Dik-dik antelopes actually use their trunks a little differently. They use them as a thermoregulation system, so like a little temperature gauge. They use it to make sure that their bodies don't overheat. And then one of the more beautiful trunks, of course, belongs to things like the elephant seal and the hooded monk seal. These use theirs for sound production and, of course, being incredibly sexy. The males will have much more significantly large trunks, especially in the elephant seal, than the females do because, yeah, attractive, right? I should point out that also this is part of what saiga use it for. Male saiga antelope have much bigger trunks, and they do make ridiculously trumpety sounds with them too. So sometimes they're multi-purpose. So trunks, there's a lot more animals than just the living ones that have trunks. And the reason we know that is because there's actually a lot of signature in a skull of an animal that had a trunk. So as an example, I couldn't find a picture of a deer sniffing. So we have an elk down on the bottom left-hand corner, a tapir skull in the middle, and then an elephant skull on the right. Here's a googly eye just to help you orient yourself. I realize sometimes skulls appear to have a lot of extra holes. So with your deer/elk, the nose hole, the part where the nose leads into the bone, is in a pretty predictable spot. It's at the tip. But the thing that makes animals with trunks a little bit different is that their nose holes are much further back. So they have this retraction of all of the nose bones. As it turns out, you can quantify all of these different characteristics into about 12 consistent skull signs. I realize that these are all very highly technical terms, so I'm going to break them down a little bit. So a short nasal bone just means that this itty bitty bone right here gets even smaller. On you, it's pretty small. I know you don't have a trunk, but on animals that do have trunks, it is also very small. They also have nose bones that end up sticking pretty far out, making this little notch next to their face. They have a big dent right in front of their face where muscles will attach. They have pug faces with their eyes further forward. They have a bump on their top lip that helps them anchor their trunk. They have a face that is very much like a pug. So the elephant is a better example where it's really just kind of smashed in the face area. They have a lot of extra lumps for muscles on various parts of their face. So the lacrimal bone is in front of your eye. The bones that support all of their like sniffing membranes are further back inside their face. They have big, thick lip bones. They have big holes for face nerves. They have big holes on the inside of their skull, and they have really fat necks. So animals with muscular trunks do not skip neck day. And the reason that these characters are so common is partly to support necks, or partly to support muscular trunks, but also essentially it's the idea of accommodation space. So if you're going to put a big old floppy trunk in the front of your face, you still need to be able to see, which means that you have to move things around in order to accommodate a much bigger fleshy chunk. So that's why you have bones moving backwards, you have bones moving outwards to help support all of these muscles, and you basically get shorter faces so that you can still see over your gigantic nose. However, I should point out that these characteristics were essentially started looking at tapirs and elephants. And remember, they do use their trunks very differently. So if you look at saiga antelope and dik-dik antelope, they actually don't have all of these characteristics. What they have is pretty well the first two. They have itty-bitty nose bones, and their nose bones stick out. And they do so in a slightly different fashion. So while these do hold true for muscular trunks, only a couple of them are consistent for trunks that are not necessarily as muscular. So using all of these characteristics, we can look back in the fossil record and realize that there's actually a ton more animals that have trunks than you might have guessed. So who had trunks? Like everybody. So we have Macrauchenia, which is a liptotern up in the upper right-hand corner. Paleontologist is one of my favorite. It's a giant wombat that had a trunk nose. And then, of course, oreodonts, diprotodons, amenodonts, pyrotheres, all sorts of different organisms had trunks. And then this is the paleontological trolling component of the lecture. Oh, sorry. Just kidding. Forgot I switched slides. So at this point, you might be, so maybe they're not really the vanilla latte. Why are you not calling them the pumpkin spice latte, right? Everybody tried it because pumpkin spice lattes are gross. Vanilla lattes are delicious, and they're pretty much a classic go-to. These trunks show up repeatedly, especially in mammals. You do see them in some other organisms, but they do show up a ton, and they stick around for long periods of time. So unlike these gross products, which presumably you can buy and give to someone that you don't like, trunks seem to be a staple and a common go-to for mammalian evolution. So for everybody means everybody. There are some really weird organisms that appear to have a lot of the same characteristics in common. Here's an eyeball, in case you're not familiar with what this dinosaur skull looks like. So Diplodocus is one of the dinosaurs that has been theorized to have a trunk. There have been some publications essentially saying, no, there's no way. Our dinosaurs are way cooler. But they all focused on one characteristic, and that characteristic is a nerve, right? So the nerve, in elephants and tapirs is huge, and they have a really big hole for that nerve to pass through. And they have a big nerve because they control their trunks. They can move their trunks around, they can forage with it, they can sneer with it and make stupid faces. But not every trunked organism can do that. So saiga antelope, for example, they really can't move it very much. They can kind of sniff it around a little bit, but it's not a trunk that is designed for moving and selective foraging. It's a trunk that helps them filter their air, and it's a trunk that helps them look sexy for their mates. So that means that theoretically, Diplodocus could still have a trunk that it couldn't move very much. It could just be a cute Star Wars character, right? So I have some illustrations. Brace yourself. So cute. Oh my God. This is why I love trunks. They're just nightmare fodder on the wrong animals. So at some point, I'm going to try to publish a paper just to make dinosaur paleontologists really angry and make them realize that probably their stupid dinosaurs looked just as ridiculous as my stupid mammals. All right, but at this point, my personal research has really focused a little bit more on the evolution of trunks and how do they start. So specifically, how do you go from something like this, just kind of your basic antelope shape, to something as majestic and beautiful as this? So in order to find the answer, you have to look at fossils. So in order to study trunks, you kind of have to have a few criteria, right? You have to have an organism that has trunks, but you also have to have a fossil record where some of the organisms don't really have trunks. And that's part of the problem with elephants. So not every single elephant had a massive, massive trunk, but as far as we can tell so far, most elephants had some form of trunk to start with. So if you're going to study the evolution of trunks, you kind of can't do it with the current selection of elephant ancestors because there's not really good representations of ones that didn't have trunks. It's the same problem with tapirs. Going back pretty far, tapirs, even back in the Eocene, already had trunks. So you can't use them. You have taiga and with thick-dick antelope. While they do have living ancestors that are living relatives that don't have trunks, there's not a very strong fossil record, so you can't really look back and see kind of this progression through time. So at this point, this is where oreodonts are here to save you because oreodonts meet all of these criteria. So what is an oreodont? I'm so glad you asked. An oreodont is the best animal in the entire world. They are named for their mountain-shaped tooth. That's what oreodont means. It means mountain tooth. Um, there's a lot of them. They live for about 45 million years. They have a huge, huge fossil record. Their skulls are really common. I heard on Twitter last week or so that they are described as the potatoes of the Badlands because they just weather out and roll down the hill. And one of the many great things about oreodonts is that some have trunks and some do not. So specifically, we're going to be talking about 3 different genera of trunks: Merycochirus, or as auto captioning likes to refer to it as America Curious. Then we have Statochirus and Brachycrus. They are 3 different genera with trunks. They have some species inside of them as well, so there's quite a few that do have trunks. So the question is, how this, just kind of a basic oreodont, this one doesn't even have a genus name assigned to it, that's how generic it is. How do you go from something like this to something that has a trunk? Well, one of the big theories is that your ancestor would have had mobile lips, right? So something where you were using your lips to help you selectively forage, and then over time, natural selection works on those to create a trunk that helps you to selectively forage. So there are organisms like that alive today. So a moose or a camel is a good example of this. Sorry, here's their eyeballs. And we do see organisms that have kind of this proto trunk. So kind of like a retracted face, but not exactly these same sets of characteristics that you would see in an actual trunk. And we see quite a few different possible ancestors. But part of the problem with oreodonts is that they have been a little bit ignored for a very long time. And in order to understand the evolution of trunks, you kind of have to understand oreodont evolution in general. So specifically, what sort of order of events do you have in oreodont evolution? Do you go where it's you have the prototrunk and then you have each of these things branching off kind of in turn? Or is it something more where you have early prototrunks and then a fantastic and very rapid radiation of trunked animals that are related to each other, right? So this is the subject of a research paper that I am submitting next month. It's going to happen, that I'm working on with Spencer Canada, Kiala Grande, Paul Barrett, and Ed Welsh, that is all about oreodont evolution and oreodont phylogenetics. So what we did is we did a lot of character coding, and we did a lot of phylogenetics. And by we on that part, I definitely mean Paul, and basically came up with a family tree for oreodonts. Now, oreodonts are not just the trunked ones and the untrunked ones. There's a lot of cool things about oreodonts, and you should absolutely study them. So, for example, some of them had claws and climbed trees. That's weird. Some of them were very small. Some of them may have swam. You know what I mean. And those two groupings do kind of break off earlier along the tree. And then what we see in our new phylogenetic tree is you have Merycochirus, Statochirus, and Brachycrus were separate. All of the proto-trunked oreodonts, so all of the things that were kind of like camel and moose, where they had kind of a big lip but not actually a trunk, actually came after Merycochirus. So Merycochirus branched off earlier than any of these things did. But we also found that organisms that had kind of these proto-trunks actually branched off before Statochirus again and before Brachycrus. So essentially, in oreodonts, trunks evolved 3 separate times. That's how cool trunks are, I guess. If you're an oreodont, they evolved all the time. But what did they evolve from, especially with Merycochirus, since there were no proto-trunked ancestors in its lineage? So if you have Statochirus and Brachycrus, they came from something sort of like this. This is Phenacocylus. Sorry, here's its eyeball. And Phenacocylus is not a great example of a proto-trunk. This specimen, a lot of the other Phenacocylus have more nasal retraction, so their bones go back, that nasal notch goes back. But these are kind of a good example of the ancestors for Statochirus and Brachycrus. However, Merycochirus came from something which looked like this. Here's its eyeball. Just a massive, massive curl of cheekbone. Those cheekbones are actually encrusted in bite marks. That's what a lot of those little lumps and divots are. And so what we see with Astatocurus and Brachycrus is kind of what we expected to see. You see them kind of coming from some sort of big-lipped oreodonts, and then you have that progression towards maybe a more muscular trunk. But in Merycochirus, that thing has a full-length snout, right? There was no sign whatsoever of any of that pug facing where things get shrunk. There's no characteristics of trunks whatsoever in Merycochirus. So a full-length snoot starter, which is actually kind of interesting because Merycochirus, sorry, here's an eyeball, looks very similar in skull shape to an organism you are probably very familiar with today, a little pig. So this is why oreodonts are often called sheep pigs. A lot of them have bodies that are shaped like pigs, and then teeth that are shaped kind of like sheep. But Merycochirus really typifies all of that because its skull really does look sort of like if you gave like Botox injections along the cheekbones of a pig, right? So they have really, really big cheekbones, but they do look very, very much like a pig. And so with Merycochirus, you basically started off with an organism that had a mobile little snout. I'm sure that you have heard about pigs rooting around in the ground, digging for things like truffles. And that is because they have a really mobile little snout. So it's the same general idea. It's just not a lip. It's a cartilage pad that they use to kind of root around. And over time, that could potentially become longer and longer and longer. And all of a sudden, you have a trunk. So with oreodonts, what they've shown us is more than one path to having a trunk. There's multiple paths, but they all kind of start with the same general idea. So the typical path is you have flexible lips, but you can also have kind of that mobile piggy-like cartilage pad, and that can turn into a trunk eventually as well. And mammals are particularly good at developing trunks, in part because mammals share a bunch of muscles that actually point in exactly the right direction that are used to move those lips around. So as a result, it's pretty simple evolutionarily to develop a trunk. And herbivores in particular find trunks advantageous. While not all of them are using them for selective foraging, that is a very, very good way of being good at selective foraging, right? So if you have a trunk, it means that you don't have to take a big bite out of whatever is in front of you. You can kind of use it to root around and find only the tasty bits, or potentially the non-poisonous bits, depending on what you're working with. So herbivores love trunks, and mammals are really, really good at evolving them. But probably dinosaurs did too, and you can't prove it didn't happen. And so at this point, that's pretty much it for this research topic and for this little presentation. But that doesn't mean that there's not a lot more questions. I personally have a ton of questions that I hope to work on for the next, 10, 50 years. Once you trunk, can you untrunk? Were there trunks in different groups? What were they used for? Are there ecological triggers, etc.? Are there disadvantages? But that's all of my questions. I figured I'd stop at this point and ask you about yours.
Awesome. Thanks, Meaghan. That was so fun.
Good.
Okay. I'm going to start off with a question already because I saw in your talk this thing that really sparked it. So movable lips and mammals can form trunks, right? Is like one of those criteria for that. How would it look if a human were to form a trunk?
Well, I'm glad you asked. It would look like this. So that is a proboscis monkey, as I am sure you can tell, that is for being attractive, because oh my goodness, right? So yeah. There are mammals that do have trunks. There are bats also that have trunks. There are mammals. We've already talked about the mammals. There's primates that do have trunks. So far, I think there's only just the one, the proboscis monkey. I have not been able to go and look at one of its skulls in like person. From what I've seen, the problem with primates is we all have pug faces. So we're all a little bit smashed, right? We have our eyes up very close to the tip of our nose. We don't look like our dogs. So telling the difference between like a nasal bone like mine versus the nasal bone of a proboscis monkey is a much finer gradation, right? Um, from what I have seen, the proboscis monkey does have a mildly more Voldemort-like skull, where the nasals are pulled back a little bit, but it's a very fine-grained difference. So it's going to be a lot harder to tell if there are other primates that have had trunks through time.
Oh, interesting.
I'm just glad we got to go back to this set of photos where I can see the baby Saiga again.
Yeah. So one of the key research developments that I made yesterday was that I didn't realize that they were this small, and now I want one so bad.
Definitely.
So little.
Definitely want one. I saw a poodoo for the first time the other day, and they're just as small, and now I just want all the tiny little artiodactyls everywhere in my house.
I mean, that antelope is the size of my miniature cow when he I could have just a whole herd of miniature animals, which literally is my dream.
I completely support this, so please do that. And if you'd like to donate to Meaghan's mini animal fund, please let her know.
I will open a Patreon if that's what it takes.
Oh my goodness. Oh, this is a great talk. Okay, we do have some good questions, so I'm going to go ahead down our chat. Here's a good question. I'm really curious. Did Oreodonts swim?
Maybe. Okay, so if I go back 1,000, this is the problem with having too many animations. Oh, there we go. Okay. So I called it itty bitty and maybe swimmies. And I put a maybe on there because the one that I'm specifically referring to here is Leptokinia, which has also been called Cyclopedius at certain points. And then Cespia is a relative. I don't actually know that the same things have been ascribed to Cespia, but really their skulls look pretty similar, so probably should be. So the thing that makes people look at Leptokinia and go, were you in the water? Is it has every every part of its body has kind of just gone whoop up on its skull. So it's got its ears have moved up, its eyes have moved up. Its nose has not actually moved up, but it kind of appears to because of the way that they get crushed. So it looks very much like the Oreodont version of a beaver, right? Where everything is moved up so that beavers can keep their head above the water as they swim. However, from what I've read about Leptokinia's body, it doesn't seem really good at swimming. Its head has all of the adaptations you would expect, but the body not so much. So at this point, I would say, hey, if you're interested in doing some research on it, let me know, because there's definitely a lot of research to be done. Part of the problem is that postcrania, so anything that is not a skull on an Oreodont, is desperately underdescribed. So it's just really not clear at this point whether they were capable of swimming. They got their head says yes, their body says, oh, we don't know, it's a mystery. So
yeah. Okay. Oh, ooh, is another good question. And it has been posited as the biggest question of our age. Can you untrunk once you have a trunk?
Oh, it is. It is potentially the biggest question. So we wanted to be able to answer that question with this particular paper. However, I've decided to do a little bit more work before we decide formally. So the reason that we did that is untrunking is not happening at a genus level, probably because Oreodonts all died. So, if only you had lived, we would know. But it could be happening at a species level, where if you have like 3 species, the oldest species might have a bigger trunk, and then the younger species might have a larger trunk. Initially, when we were doing this phylogenetics project, that happened in some of the trees, but not all of the trees. So it wasn't commonly supported. And part of that is because the way that we were doing our phylogenetic trees is We actually used individuals, so we had like multiple members of a single species rather than just species level, because the species level taxonomy of Oreodonts isn't really good. It's really, really complicated. There's probably too many species in some area and not enough. So in order to answer that question, like formally, officially with Oreodonts, I'm going to have to do a little bit more taxonomy and figure out exactly how many species there were. We also have to understand a little bit more about variation. So for example, if you look at my nose versus your nose versus Britt's nose and Gabe's nose, we all have very different noses. Legitimately, if you looked at Oreodont skulls at this point, some of the species that have been named are just as different as my face from Gabe's face from Britt's face. We're all the same species, they might be too. So nobody has really kind of quantified how much variation should be happening, particularly in those nose bones within species. So like, do you have one individual tapir that has a really, really short nose bone and then another individual tapir that has a really, really long one? We don't know at this point. So yeah, there's a couple of things I have to answer before I can answer that question, but maybe.
But why would you want to untrunk when it makes you so cute?
Actually, there is do you guys want the depressing real reason as to why you would definitely want to untrunk?
Yeah, hit us.
Yeah.
Okay, I decided to not put this on the slide because it was my last slide, and then remembered that, you know, maybe depression isn't the way we wanted to end this. So someone else has to ask a follow-up question about something that's not depressing. So in 2015, 60% of Saiga antelope died in about a 2-week span because they got a respiratory infection.
Oh no.
And they weren't able to fight it off. It infected a lot of other animals at the time, but it did not kill them. And the thing about trunks is, first off, that's a lot of biological energy to be putting into a structure. So if it's not something that's useful to you, you're basically wasting all of your energy trying to maintain that thing. But one of the characteristics that we do see in most organisms that have a trunk is they reduce, because they have to move all of these bony bits back, they actually reduce the amount of the bony bits that are supporting these membranes that you use to filter out your air, that you use to keep your body warm. So you're basically reducing kind of this respiratory like filtering system. So Saiga might be really good at getting rid of dust, but that slow settling system appears to make them potentially more at risk of disease. This is actually something that has happened periodically over the last like 20 years with Saiga. The one in 2015 was really, really bad, where a ton of them died. But you know, you have like 10,000 die from a random respiratory infection every couple of years. I will say Saiga, apparently, you know, those noses, they are hot to Saiga, so they breathe like rats. So basically, but yeah, they might potentially actually be a bad thing at times.
Oh.
Okay. I mean, that's like evolution, right? Like, yeah, it's all testing, and it works or it doesn't.
Happy Friday, everybody! So many snoots. Okay. Let's see. Here's a question: are giant cheek flanges in some peccaries and entelodonts possibly relevant to trunk-like structures?
Like the cheekbones?
Yeah.
Probably not. So if, man, we just left that slide. Dang it.
Sorry.
Okay, go back. So the giant cheekbones in Primaricochirus, this is another project I have to finish up at some point. Man, so many. They are not necessarily associated with trunks. You can actually see some signs of muscular scarring on them, but that scarring is heading back towards the neck. So probably the muscles that were attaching to the cheekbones in Oreodonts that had big cheeks were neck muscles. Those cheekbones also are pretty clearly sexually dimorphic. So the boys might have had bigger ones, the girls would have had smaller ones. They are covered in bite marks that are healed, indicating that for whatever reason, these cheekbones are getting bitten a lot, probably because these are some sort of, dominance display sort of thing. So the massive cheekbones in Oreodonts at least seem to be kind of I'm so good looking and also I can smash your face. Whereas the cheekbones in entelodonts, there's been a study that showed that they're actually probably used for gaping, like in hippos. So hippos, if you Google image search tapirs, you get all of the pictures of them sneering and looking stupid. If you Google image search hippos, you get all of these pictures of them being really scary and showing you their massive teeth. And they actually have really wide jaw bones, and their cheekbones hook up to those so that they can drop their jaw way further to show you their scary, scary teeth. And entelodonts seem to have the same setup. With oreodonts, the cheekbones are really far out, but the jaw bones don't follow suit. So probably they weren't gaping, they were for smashing or biting or showing off.
They're still scary, honestly.
Yeah. Oh, yeah.
Yeah.
Massive cheekbones.
I have a picture somewhere of myself standing in a hippo jaw because my hips fit into a hip. So don't mess with it.
Wait,
thank you.
So earlier you said that what did you say that the name of Oreodont meant?
Oreodont meant?
Or what does Oreodont mean? Like, how does that translate again?
Oreo means mountain and dont means tooth. So mountain tooth, because they have really spiky little teeth.
So does that mean like the Oreo cookie means mountain? Now I need to look this up.
Yeah. Mountain cookie.
Mountain cookie. Yeah, I can see it. Now I'm hungry. Thank you all. Yeah. I want an Oreo. Alrighty. It's Friday, everybody. And it's the Friday before Halloween. So, okay. Here's another question. Would you consider, I'm going to mispronounce this, which everybody knows I mispronounce things here. Would you consider Leptopterns? Those, you know what I'm talking about, to have the kind of proto-trunk you mentioned, or a full-fledged trunk? I've heard that their skulls don't really have some of the traits you mentioned that indicate trunks. So, like, what does that mean for them?
Let's see. Can I figure out how to actually just go?
There's just so many googly eyes.
So many animations. Why did I do this to myself? I call them Leptoterns because I always forget that's not how they're spelled. And also that contains the word lip, and that's funny to me. So Leptoterns are really weird. I like to think of them as the llamas. So this is a Macrotenia is a Leptotern. And you can see it's got the nasal hole has gone all the way back up here. It almost looks like a whale skull, but they definitely weren't aquatic because they have llama bodies, and llamas are not historically known for their swimming ability. They do have actually quite a few of these suite of characters. The thing that they're missing is they don't have that nasal bone that sticks out. However, I'm not a big expert on South American mammals, and I've never actually seen one of these in person. I do know that at least in oreodonts like Brachycrus, those nasal bones are so small, they fall off sometimes. So it might actually be just that the nasal bones were really fragile and you can't see them in skulls. I have not seen enough of these skulls or seen any of them in person to know whether or not this scarring that I can kind of see dimly on this pixelated image, if that's actually from a broken fossil or not. They have a pretty large infraorbital canal. Then the other thing that you'll kind of notice, can I draw on here? Yeah, I think I can draw. I have the capacity. Highlighter. No, not highlighter. Let's do pen. Let's commit. Okay. So you'll see that this is where like the hole basically for the nose is, this whole thing right here, which means that the lip bone, so the premaxilla, it fuses all the way back there, which is really far back. Kind of unnecessarily far back. If you look at oreodonts, most of the trunked ones do have that kind of fusion point. With tapirs, they also have a little bump. It's not that obvious on tapirs, but they have a little bump there from muscle attachments. The fact that the premaxilla is so robust and fused, to me, is a good indication of a trunk. So I would interpret, from what I've seen of Macrotenia and other Leptoterns, I would assume that they do have a trunk. One of the things that I do want to study in the future is there's some indication that you can look at like microscopic muscle attachment sites on the bone. Nobody has determined whether or not you can use that to find direction of muscles or if you can use it to interpret size. So I would really like to look at this spot on Macrauchenia and see if there's actually like lots of signs of muscle attachment, because that might be a good indicator.
I'm trying to not laugh because Paleorchestes is my new favorite skull in the whole world.
It's just the googly eye.
But
It's too much.
You guys can tell it's actually got the opposite thing here. So that's the fusion point for the premaxilla, and then they've got this big gap. Probably because their trunk was like fat. So I bet there's lots of muscle attachments right here. Probably it didn't go this high, but you know what? It's Halloween. That high.
Yeah. You can't prove it to soft tissue. We don't know. Oh.
I don't have to figure out who did this illustration, because this oh my god, it's my favorite illustration of all time. It's even better than the nightmare Diplodocus that Mark Whitten made.
They look like they're judging us.
Mm-hmm. Which, I mean, they should. If anyone's judging this, you guys.
Okay. Oh god. Okay. Here's another good question. It is a very good question, and I want to know the answer. So, okay. Are there any differences in how trunks evolve in marine mammals like elephant seals?
Ooh, I don't know, actually. I have looked into it a little bit because I'm curious to see if you can kind of trace that evolution, because, you know, marine mammals, they live in the ocean or nearby, which means they actually have really high fossilization potential. So you have really good records for marine mammals. Oreodonts are kind of the exception to the rule for terrestrial mammals. Oreodonts have like bowling ball heads, so they fossilize really, really well. But other mammals, like tapirs, it's harder to find a well-preserved skull because they just don't have as hard of heads. And then terrestrial mammals don't preserve as easily. So yeah, I'm not sure. I do know that I've looked at some of the skulls of seals and sea lions, and they have the same characteristics. Like, they have the nasal retraction. You can pretty clearly see that, but I have not looked at their fossils. So I don't know the answer to that one.
I'm very curious now.
That's awesome. Yeah. So, Meaghan, like okay, paleontology, we look at bones, hard parts, whatever. How does a paleontologist go into looking into something that doesn't preserve in the fossil record? Like, how did you become interested in studying these things?
So even though the actual like soft fleshy bits don't preserve, first off, as a paleontologist, I prefer that because fleshy bits are gross. Bones are clean and not as disgusting. So I'm digging that. But what you're really looking for is you're looking for proxies, right? So this is the whole field of functional morphology and comparative anatomy. You're looking at modern animals to see if there's something that relates to the fleshy bits that's on the bone that you can then go back in time and look at the bones of other organisms and determine it. So people have known for a long time that at least some oreodonts have had trunks. There's not been a ton published on it because nobody likes oreodonts, and they should. Oreodonts are the true pumpkin spice latte. Everybody's like, oh, oreodonts. Oh God, their taxonomy is so bad. Never mind. So I'm gonna change that. They're gonna be the vanilla latte for paleontology too. But yeah, so oreodonts, it's been published for like, I think the images I showed you, those ridiculous heads of oreodonts, those are from 1915. So like we've known for a long time what the bony proxies are. When I got into oreodonts, it actually wasn't for trunks. I just was pissed off that there was so little research done on them when they were such a big part. I used to teach at the Hancock Field Station run by the Oregon Museum of Science and Industry, and we would talk about oreodonts all the time. And every time that, because that's all you find out there, every time that I would try and like find more research on it, there would be nothing because people just haven't really looked into oreodonts. So it's like imagine a world where nobody knows what deer looked like. Like that's how common oreodonts were. The deer and the rabbits and the peccaries, they were everything in North America, and yet we know so very little about them. So I'm focusing on trunks because after getting into oreodonts, I thought that that was the most interesting bit. I will say that there are some proxies that I've actually noticed in my research that other people have not noticed. So at some point, I will be publishing a paper on that. But yeah, the pug face thing is a pretty good giveaway. It's not a subtle face, as you can see with Paler.
I think you've convinced me that like oreodonts actually are much cooler than like some people have led me to believe. I know like when I was starting in paleo, you know, as a mammal person, some people will unfortunately say like, "Oh, oreodont, those are the trash fossils." So
poor oreodonts.
But they did everything. Guys, there's beaver oreodonts. There's literally oreodonts that climb trees. There's maybe oreodonts. There's some evidence that oreodonts burrowed with hooves.
Wait, hold up. Cool. Back up. Beaver oreodonts? Are you serious?
Leptokinia. Their heads look 100% like a beaver, except their teeth are a little different. But they were probably eating grass and not eating trees. But I don't know. Nobody studied that, so you can find out.
And see, this is a reminder to all of our young paleontologists watching. Just find a gap. Find the weird creature that somebody else hasn't studied because they thought it was boring or trash.
Yes, exactly. Unfortunately, part of the problem is that a bunch of people did study it, but all they did with oreodonts is name every skull as a new species.
Oh, Meaghan, I study. Meaghan, I study horses. That I feel that.
Yeah, you guys have similar. Actually, there are horses. I forgot to put horses on here. There are some horses that probably had trunks.
What?
Yeah.
Okay, I'm gonna be down a Wikipedia hole later today, so.
Oh man,
Wikipedia, my common names. I may have made those up. Nobody calls soda ungulates hoof imposters, but they should. That's what they are.
Nosy llamas. It's like that old meme. Tag yourself. I'm fake elephants.
I'm excessive armadillo. Exactly. I'm definitely excessive armadillo.
Oh my goodness. Well, Meaghan, thank you. Thank you so much for this talk, for showing us, oreodonts and trunks, and showing that they are truly the vanilla latte of the fossil record.
That's right. That's right, guys.
And thank you, everybody, for joining us, because I think we've all been on a journey together today, right before Halloween.
That's for sure. I'm going to be defending oreodonts from now on because they definitely deserve it. And I'm going to look into these beaver oreodonts, and I'm going to be wasting a lot of time later looking up horse trunks.
Great.
Yeah, I know. I feel like now we need a team shirt that says the Oreodont Defense Squad.
Yes.
I've made shirts for everybody that's on this paper. That's the Oreodont Dream Team.
Oh,
yeah, same.
Love it.
Same. Oh, well, thank you again, Dr. Wetherell, for joining us today.
Yes, thank you
for having me.
And
thank
again,
you.
Go ahead, Britt.
Okay. Go for it, Gabe. You got this.
It's been a while since we've been on Fossil Friday Chats. We're out of our sync for a little bit. But yes, thank you all so much for watching. As usual, if you like this program and want to continue to support it, you can find links on how to do that at both the Alf Museum and the Western Science Center in the description below. If you want to find out more about Dr. Wetherell's work, we have those links in there too. And as always, please make sure you like and subscribe to our channel for more Fossil Friday Chats and a lot more cool fossils things coming up. Thank you all so much, and we'll see you next week. Bye.